Okay, hopefully I don't miss that part. Come on. Okay, so now we were, okay, now just a summary, guys. Yeah, oh, this is my private email. You can see now. Look at this. Okay, come on. So until now, we just look at the basic fundamental bearing capacity equations, right? But for the one layer of soil, what we do now, what we do now is what happens when we have a different layer of soils? Okay, I'll start from here, go briefly. We'll solve one typical problem, and then I'll overview everything, and then we'll finish. Hopefully, it doesn't take that long time, right? Look at here. Can I explain a little bit before going this lecture note? Lecture note are sometimes not that good. Come on, here you go. You see, if this is a ground, right? Yeah, ground surface, and we put a footing here. Let's write a very basic footing things, right? We put that, and then until now, what we use is we have only one type of soil. Yeah, type of soil. What it is either it is a only phi soil or only C soil or sometimes C5 soil. You know, right, what I'm talking? Phi soil means only cohesionless soil. There is no cohesion. And the C soil means is no phi, just the cohesion only. And the C5 means mix of both. Okay, this is a type of soil we classify, right? But now what happens if we put footings on look at this, different layers, right? Maybe let's say this is one layer, then another layer, whatever. You see, if we put here, what happens is, you know, the failure things goes like this. We learned that in a Trezacki theorem, right? It goes like that, and any other theorem also. And so what happens this, you see, we put footing in this layer, layer 1, yeah, but it's a failure goes to layer 2 too. Layer 2 too. And maybe layer 3 also. You see, it can go anywhere. It depends on this angle alpha. Alpha is usually given by, based on the different guys, they say 45 plus 5 by 2. Okay, if we do this, and if it goes to the lower level, then which bearing capacity factors we use? That one, or we mix it? We do what we do in this case. For me, okay, as a designer, geotechnical foundation designer, if this is very, what they call very small thickness, this, right? Let's say 1 meter, half a meter thing. I don't feel good to put over here, right? I will move this footing, just put over this soil only. You see, you know the practical way of doing things. You can't just, you don't know how the failure occurs. So why you worry about that? In this case, you can use only layer 2 bearing capacity parameters to compute, right? And so that's how we do. But let's learn few cases where this can be the situation. I don't think that we will have many layers. Forget it. If many layers, this is, we don't consider this as a layer, right? So you need to have maximum around 2 layers is enough for the foundation design, right? Layer 2 and a layer 1, right? You don't distinguish too many layers and complicate your things, right? If they are very thin layer, just scavenge it and put it there, right? If they are very thick layer, then you need to have maximum around 2 layers is enough for the foundation design, right? Layer 2 and a layer 1, right?
Who's the boss now?
Are you guys
Daniel,
there?
you are the boss.
All right, I'm the teacher now.
Yeah.
All right, let's wait for him for show up again.
Yeah, I think connection problem.
Sorry, guys. I moved to the another computer. Hello, can you hear me?
Yes, we can hear.
Oh, okay, sorry, guys. Yeah, that happens. That's what I was talking before. Hopefully, you got it. What I mean. Oh, there you go. Okay, now. Sorry, I share the screen now. And I need to connect my USB here. What is that? Now it should be all good. Yeah, there you go. Okay, so now sharing is done. So I will open my, sorry guys, slide and then we will start immediately. So go to the, where is that? That one, and then there is a file, and here you go. This is the one we are doing now. So in this computer, I cannot write like this, so I need to explain with the resources. Can I go to the slide? Yeah. Where I was talking. Oh, so many slides, eh? Yeah, this one I was talking, right? So different layers thing we gotta do, right? Can I use the pen? Okay. So usually if there are many layers, we don't try to make so many layers. Around 2 layers would be enough. There are 3 cases, right? In the case 1, you can hear me, yeah?
Yep.
And then also you can see the slides, isn't it?
Yeah.
Okay, good. Case 1 is just a phi equals 0. What that phi equals 0 means? It's a cohesive soil, right? It is not cohesionless, right? So cohesive soil, that means only C value. You know the cohesive parameter C phi I was talking about, C and phi. I can't write that well now. I'm in trouble, but anyway, here you go. So second is whether the first layer, let's say this first layer is C1 and the second layer is C2, right? In this case, what you need to do is how we calculate the bearing capacity in this case. That's the first case, right? In the second case, this is C5 soil. That means both type of soil, right? It can be any cases like this. And third case is just this is what? Sand and clay. One layer is clay, another layer is sand. Or what that means is one layer is cohesive soil, another layer is cohesionless soil. Right? These are the 3 cases we can have. So first we need to check is this angle, where this depth of failure occurs, right? Using the phi. Phi is always, as I said before, 45 plus pi by 2. Is it all right? Okay. So now, so you first calculate h and then check whether the depth here is less than that or more than that. If h we calculate from that equation is less than what is the depth available there, so that means failure doesn't go to the next level. So we can use the parameters from this layer, right? So let's talk few things, right? If this first layer is very weak, usually it may also occur the failure around this by slipping. The soil at the top, if it is very weak, it may just slip the top layer. It may not go like a circular arc way of failure at the bottom. Okay, you need to consider that. Let's understand the case 1. Case 1, what is the case 1? Case 1 is both layer cohesive soil, right? It can be upper layer beta C value or lower layer beta C value. So what you need to do is you need to calculate the ratio of those cohesion value, right? And then use appropriate formula to calculate the N factor. You see the first NC factor at the beginning? You see the first term in the equation NC? You need to use the first one. For cohesive soil, other factors are what? NQ and gamma are not applicable. NQ is 1 and N gamma is 0, right? So that means the other two terms will not come into effect, right? That much. So only the first term. So there are different formulas for different stiff footing, round base. Let's put this to somewhere. Round base or something, right? So you just calculate the combination. So you calculate NC value, yeah, by using this equation, and use the same bearing capacity equation we considered before. This is the approach discussed here is calculate the combined value for the two layers, right? And then we use that for the bearing capacity equation. It's nothing new, just use few equations and then you will get values that is required for the layered swell. Okay, so second case is what? C5 swell. What we do is we modify the phi value using this equation. What is this equation now? This equation is first layer depth, this one, and what is the phi value for the first layer? This is the what is the depth of the second layer, right? Which is, of course, we don't go below the H value, right? Up to S value. And then we combine that, we also calculate C5. This is the combined calculation, you see. Can I explain a little better, hopefully, all right? There are two layers, you see? So let's say this is phi 1 layer, yeah? This is phi 2 layer. How to combine the phi value is this. You calculate combine phi value. And then we also calculate combined C value using this similar equation. And then we use those modified phi and modified C value to use in the bearing capacity equation. We already learned those equations to compute, right? Yeah. So now this is the third case. Third case is sand over clay or clay over sand. In this case, there are few steps we need to follow. Using some equations, you compute the bearing capacity of the first layer, you calculate the bearing capacity of the second layer, and then you also calculate few other punching contribution things, right? So can we do this, following this example, can we do one problem now? Sorry guys, I cannot write now, so you need to write. Can we do the tutorial problem? Because my writing pad doesn't work on me. I need to. So that's why I need you guys need to compute. Can we do the problem now? We're using this method. Okay. So let's say this is a tutorial problem 110, and this is the case. Can I explain the case now? From this above is this is the sand layer. Yeah, sand layer, and this is the below this is clay layer. Over here is the clay layer here. All right. So now, first thing you need to do, you put the foundation here. You see now? Can I see this now? Just draw the foundation where that is. Yeah. So now you need to check whether the failure goes to the clay layer or not. If it stays within the sand layer, then you don't need to worry about underlying clay. Okay. So this is just the sand layer. But if the failure goes down to the clay layer, how we compute the bearing capacity? That's what I'm trying to explain now here. Can I do now? First, you need to check. You see alpha equal, how much is it? What is the phi value for the sand layer? Come on, 34, right? What will be the alpha value now? 62. Can you calculate how deep the failure goes first? What is the H value? H value. H value is using this equation. Right? Can I show you what that equation is first? This is the equation to calculate H. Can you copy this equation first, please? V by 2, 10, 45 plus 5 by 2. Can you copy that somewhere? H equal? Can you compute H now? Can you? How much you got H value? So B by 2, can I do now just over here? B by 2, what is the width of the foundation for our case? It's how much is it? 2 meter, right? Yeah? Can you do that over there now? So now H equal 2 divided by 2, okay? And the 10. So 45, what is the phi value in our case? Phi value in our case, what is the problem? What's the phi value for our, I'm talking about sand layer first, whether it goes down or not, right? 34. Can you do that now? So did you get that now? 1.88 meter, is it?
Yeah.
Okay, so if that means how much depth available now? You need to check depth of the first layer. How much is it? 0.6 meter, right? So that's why failure goes to the clay layer, right? Failure doesn't stick with the sand layer only, right? Because the D1 thickness is just what? 0.6, right? But the failure from here, H value we got is 1.88, right? So that means failure goes to the second layer. So you need to consider the clay layer also in calculating bearing capacity. You understand? Okay, let's use the Henson method. Can you use the Henson method now? So what you need to do in this case is you calculate the bearing capacity of first layer, sand layer Q first, and you also calculate the bearing capacity of the clay layer. Let's say Q is clay, this is Q sand, just that. And then there is a way to combine them together. Okay, can we do now? Can we use the Henson method? Can I? This is solution here. Can we check the Henson method now? What is the equation for Henson method? Because this is a vertical load. Yeah, there is no eccentricity. Forget that. There is no what? No inclined load. All other correction factors are what? 1, right? Just the simple Henson equation. Can I do now? Q equal, what is that? I'm writing using the mouse, right? I'm not using the pen because this computer pen doesn't work, all right? So now, can I write C, NC? Of course, that will not be the term for the sand layer. I'm talking about the sand layer, the top layer first, all right? NC plus what? What's the formula? Q NQ?
Gamma.
S what?
Gamma.
And then how?
Sorry.
Gamma B and gamma, right? But again, we need to correct because that's a square footing. So you need to correct for the shape correction. Can I put that now just here? Shape correction SC, SQ, and S gamma, right? We also need to correct for the depth correction, right? Depth correction is what we call DC, DQ, and D gamma. Gamma, but because this is the sand layer, there is no C value, so this term would be 0, right? Straightforward. Yeah, so now you don't need to calculate SC, you don't need to calculate DC because that's associated with that, so it's 0, right? Can you check now the Henson equation? Can you check the Henson equation? What is the let's say SQ and S gamma correction? Can you do that now? SQ and S gamma Henson equation. Can I show you the Henson equation? Okay, can you go to the Henson equation now? It takes time now. I'm taking a long time. Henson equation. Can you write all those factors first? And then it will be easier. Henson, right? This is the basic equation, Henson equations, all right? Come on. So this is the one, right? So now, so there is no load inclination. We don't apply this correction. There is no ground inclination. We don't apply this correction. No base inclination. We don't apply these corrections, right? You need to correct only what I said before is the shape factor and then depth factor. Okay. For shape factor, Henson is this equation, is it?
So what happens if B dash L dash now, guys? Can you tell me what happens B dash L dash in this case? Is there any change in effective? No, it will be original size. The reason is loading is not eccentric. We don't know that, right? So B dash L dash becomes the original B and the L. All right. Can you copy this Henson equation? SC Henson that, and the SQ Henson that. Oh, of course you don't need SC. Why?
We don't need SC. C0.
Yeah, we don't. So don't copy that. Sorry. Yeah, because if 0, then you don't need that. So only you need this. You need that, and then you need that. Can you copy this, please, guys? These two equations. Okay. And also we don't need the C things, right? Yeah, even for the depth, right? So only you need dq, and the d gamma is always 1, isn't it? Yeah. So can you copy these things, and then we'll go to the tutorial problem. Okay. So can you write this equation 1 plus B dash by L? How much is it now? Can you compute now for the sand layer? 1 plus what is B? 1 point. How much is it the width of the foundation in our problem? Can I check from here? Width is 2 meter. Yeah. Yeah. So then 1 plus 2 by 2, 2 divided by 2, right? Times sine phi. Sine, what is the angle of friction for the sand layer? 34.
34.
Yeah, can you compute now? Okay, I think you know where to get this equation. Yeah, where to get these equations, so I'll go to the tutorial, right? You know where to get those factors and the things, right? Can I go back to my... Yeah, that's it. So, first thing is, what is the 34? Is it the angle? Angle is 34, right? Can you check for the 34? What is NQ, N gamma? Well, we don't need NC because C value is 0. So that means we don't need the first term, only NQ and N gamma for 34 degree. Can I check first that? I want to show you really where those values are. You need to be very careful while using. You see Henson, right? You want that one, right? And then you want these are same for all guys, right? So what is the angle we are using? 34? Yes, right. You need to say. So can you copy this now? NC is 42.14, NQ is 29.4, and N gamma is 28.7. Can you copy that somewhere? Can you put it on your piece of paper? 42.14, 29.4, and 28.7, right? You don't need NC, so you don't need to copy just these two because C value is 0, so it will be easier. Okay? Only two, 29.4, 28.7. Got it, right? Okay, here you go. Okay, now look at here. So we got this NQ value, that N gamma value from there. So SQ, is that the formula for SQ we copied before? Yeah, it is 1 plus what? B dash by L dash sine phi. But B and L are same, so these guys didn't write here. You see how clever they are. So B by L is what? 2 by 2, so it's a 1. So did you get this 1.56? I think somebody already computed that, yeah?
Yes.
Did you get 1.56?
Yes.
Yes, okay. So what is the S gamma? What is the equation for S gamma? That's a long equation there, right? Yeah, no, not long equation. 1 plus point something something. What is that? So can you write that equation now? S gamma equation. Do you want me to show you, or you are okay?
Yeah, we are okay.
I think you are okay. The same table anyway. So did you get 0.6 from that equation?
Yeah.
Can I go back? When you are calculating, I want to just confirm with the showing things. Oh, what is that? Henson, right? Henson, this is the one, right? So we are calculating S gamma, right? Shape correction for gamma. So 1 minus 0.4 B by L. B and L are what? Same? So it's a 0.4. 1 minus 0.4 is 0.6. Yeah, you got that, right? So also the same. Can you write this for the DQ equation? And then you write that. First, you need to check whether D by B is less or equal to 1 or not. What is the depth for our case? Depth of foundation. 1.5 meter. Yeah, 1.5 meter divided by 2, so less than 1. So K value is just D by B. Very straightforward, right? So can you put D by B here and then compute using this DQ value? Okay, so let's go to the tutorial problem. Yeah, that's it, right? So DQ this is the equation they use, right? Yeah, did you get 1.2? This is what? 1 plus tan phi, 1 minus sin phi square K D by B, right? That's what they have. This is D, this is B, right? They all computed this all from the table. You can directly take this value from the table also. All right. So how much you got? 1.2 is okay? Check now. Yeah, it's okay, right? So D gamma is always 1. So can you come put the bearing capacity equation now? So this is the second term, 1.5, 17.25 is the gamma given, 29, maybe you write 29.4. Look at these guys, why? There is 29.4 here and they just write 29, just rounding these values, okay? And then 1.56, what is that? We got here, right? Yeah, shape correction, the 1.2, which is the depth correction, right? For the Q value, second is this is half, this is gamma, that's the width of the foundation B, that's a 29, which is what? This is 28.7, they write 29, right? But you can use the actual value anyway. So that's what it is. This is the correction factor, shape correction factor, depth correction is 1. Did you get this value now, guys? Come on. So what? Ultimate bearing capacity for the upper layer, sand layer is 1700 kPa. Is it all right, guys? Okay? You need to say okay, yeah? I can't just keep on talking. Okay, so now can you do the same thing for clay layer? You see, use the Hansen equation again. Hansen equation for clay layer, you can write like this, Q equal CNC, of course, correction factor are there, all right, okay? CNC plus, I can write Q dash gamma. That's it. I can ignore others. Can anybody tell me why it is the case? Because there is a clay layer means there is a no phi. Phi equals 0, right? Yeah? Phi equals 0 means the third term in the equations becomes 0. I'll show you where that is. Okay? Can I go back to the Hansen equation again in the table? Look at there. Phi equals 0, right? This one. What is NC value? 5.14. NQ value is 1. When N gamma is 0, that means what? All, oh sorry, yeah. So all the third term is 0. Okay, only the second term, even the constant is 1, so you don't need to write NQ. You see how quickly it becomes a very small problem for the clay swell. Okay, so that's what it is here. Can I go to that now? Okay, here you go. You see, so that's what it is. You see 5.14 we got from there, and of course we use this shape correction things, right? So based on that phi equals 0, right? When you use shape correction, can I do now? This is NC 1 point. What is NQ? NQ is 1. N gamma is 0, so there is no third term. Okay, only the first and the second term only. So can I write now just that one? So what is S value? Can I go and show you? When phi equals 0. Again, remember, for the clay layer, phi equals 0 here. All right? Can I show you in the table? What is that table? Come on. A correction, right? You see? Now. So now what happens? Oh, so many writing here. Can I just remove those first? Skip now. Discard, and then can I project it again so that I can show you what I'm talking about. So now, here you go. Okay. So now, in our case, in this case, we are learning about clay layer. So what? You need to use this equation for SC. You see this equation. So what is B dash by L dash now? Is what? B by L, which is 2 by 2, is 1, right? So it's just SC is always 0.2. Okay. So now what is SQ? SQ is this, right? You need to use this equation now. For any phi, right? For all phi they have written. So in this case also it will be similar to previous case, right? And then n gamma is also the same as before. But we don't need n gamma in this case. Why? Can anybody explain why we don't need n gamma? Yes, gamma, because n gamma is 0, right? It's a clay soil, third term is 0. If the sand soil, first term is 0. If the clay soil, third term is 0, right? Middle term, it comes into play. So we need only these two, that and that, as well as DC correction also. That equation, oh no, 50, this one, not this one. 50 equation, and then we do need this SQ, this value, DQ value. Okay, can I go and show you now where these equations are calculated? Okay, so NC from the table, SC value, that's what it is, right? So it's a 0.2 already, we got that. And SQ, DQ equal 1. Okay, so that's the second part, is 1, right? You can compute from there also. Phi is 0, right? Yeah, you understand what sine phi 0 means? That second term is all 0, this is a 1 now. Okay, and then DC also we compute from this. Yeah, and then we get this value, 3 correction factors, and then we put in the equation. Did you get this value now? Can you compute all of those?
We need to take a D total, right? 1.5 plus 0.6.
Yeah, because we are going in the clay layer down. Yes, we need to take the total. Correct. You are right. That's good. Yeah, because we are looking where layer we are looking, so you need to take all the depth until that layer. Good. Yeah. So that's why this D value is 2.1, not 1.5 or 1.8. Yeah. Okay. So that's the reason why they have this. Because you see, this is a sand layer, and there is a clay layer here, right? So now there is a depth total is what? I think 0.6 at the below the foundation, and 1.5, I think, above the foundation 1.5, and below the foundation 0.6, right? So total for the clay would be what? 2.1. Good. Yeah? 2.1 meter. So did you get this value now? Second layer? Compute. Do your calculation, all right? Yeah, if you do here, it will be more clear. We can talk why that is the case and so on. Okay, it's good, yeah? Let's move on to the next step. So what we did until now, we calculate the bearing capacity for the first layer. We also calculate the bearing capacity of a second layer, right? We have the two bearing capacities, right? Can I go back now? Look at this. The theory is, once you get that, you need to combine using this equation. You see, this is the equations to combine both of them, right? Can I do now? Can I show you in the calculation? What we did is, now to combine that, can I see that now equation? You see, you need a lot of values, right? P value, PV value, there are pressures, and there is description here. You can have a look, right? So PV is given by this equation, right? So we try to compute that, and then we calculate P value. Where is the P value? P is given by this as a parameter, right? If it is a punching contribution, P value is 2 times beta plus L, and the PV value is given by this equation, and then Ks value is what? You see, usually we do lateral loss pressure coefficient may range from that or just K naught value. K naught value, I'll talk about in lateral loss pressure, is 1 minus sin phi. Always is at rest pressure coefficient. I think you did that. So let's just use this equation for now. Can I do now? Come on. Yeah. So what I did is we first calculated PV. Can I explain now? This is the passive punching contribution, we call it. So Q dash D plus that. The equation is given before, right? Can I do now? PV. What is Q dash? Q dash is gamma, right? And then this is D, and this is gamma. And so 0.6 is the D1, the first layer, sand layer thickness, right? Below the foundation. And then again, so gamma is 17.15. So now when you take over, like integrate over 0 to D1, that's the total thing, right? So it becomes what? H squared by 2. Of course, ds is h squared by 2 in integration, right? So you get 0 to 0.6. Did you get this value for the punching contribution? 18.6, just using those equations. And now we calculate K naught using 1 minus sin phi. What else we need? Can I check now equation? So what we calculated P. What is P? Can I do that now here? So 2 times, what is the width of the foundation? 2, right? What is the length of the foundation? 2, right? It's square footing. So it is total is what? 8, right? So 8, PV value we have just computed now, right? Ks value is, depends on K naught. K naught is the at rest or pressure coefficient, which is 1 minus sin phi. I'll talk about this detail when we talk about retaining wall design, all right? Okay, this is the sin phi. Can you compute that now? How much it will be 1 minus sin phi in the first layer? Come on, 1 minus, what is the, I think sin 34, is it? Sin 34, so it would be how much? Can you compute K naught? We are computing Ks now. So 10 phi, we already know, area of the foundation. P is we already computed, and the D1, 0.6. C is the second, the coefficient for the second layer, and the area of the foundation. Yeah, easy. Come on. Can you put that now? You see now we got PV this, and the K naught we got how much? 0.44. Did you get this? 1 minus sin 34, right? And then everything you put in this equation now. Can I do now? What did I get this? 622. That's the second layer, the ultimate bearing capacity we computed for clay layer, right? And then these all other values we computed now, right? Yeah? And then perimeter. And then this value is less than ultimate value of that, right? So that means we need to use the smaller value. The smaller value you need to use, because once you get the combined value, and then that is the 1800 is first sand layer, isn't it? Where is the 1800? Yeah, okay. So now, can you compute that? So you get you use this minimum value 633 and then divide by 3. This is maybe, let's say, around 200 kilopascal is the ultimate bearing capacity of what? Combined things, right? So combined layers. Can you answer why we don't use this second part? Because we need to look at the upper layer. So upper layer there is C0, right? So we don't need to worry about that. Maybe you do this, sorry, because I couldn't write and show you because of the computer issue, but, right? So this is how the solution is here, okay? Okay, so now, forget about these many things now. What we did channel bearing capacity equations for one layer. And if there are multiple layers, there are steps to follow, right? We need to calculate the combined bearing capacity for different layers using these systems. So now another problem, now we look, and I move this down. So now how we get the bearing capacity from the SPT, standard penetration test, right? Look at this, Erzagi and Peck, they have given us direct formula for allowable bearing capacity based on what they call SPT number. You see, SPT number, the KD is the factor, right? So now that is given by this equation here. And then F1 is factor in the table here. So you can directly, based on the measured N value, which is N55, you can directly get the allowable bearing pressure. Okay, you go to the field. This is another method, right? You go to the field, have a SPT test, and just use this formula applicable to calculate allowable bearing capacity. Straightforward. One example is given here, right? The example, how to use this graph or these equations is given here. You can have a look. Okay, can I explain now? Let's say, how you find the allowable bearing capacity from the SPT value? So what we do, let's say N70 we observe is 24. We need to convert this N55. That's what it is done here. N55, 24, 75, 55, which is 30 you got. So now if depth of footing is 1 meter and the footing width is 3 meter, so in this case, what you need to use factor? You have factors. Can I check here at the bottom? You see? So now, what is the factor F3 and F4? So we will be using SI factors, F2 and F3, I think. These two factors we need, right? 0.08 and 0.3, right? That's what it is written, F3 and F2, yeah, correct. So these are the two factors we need, right? Because why two factors we need is, we need to first check whether the width of the foundation is more than F4 or not. What is the width of the foundation here? 3 meter, right? Can I go back? So now B is 3 meters. What is F4? 1.2, right? Yeah. So that is 3 is greater than 1.2, isn't it? Right? This is correct. So we need to use the second equation, not the first one. Okay. So this is the equation. So you need F2 and F3 factor. You already have N55. You know the breadth. You can calculate using this. KD value is given by this equation. All right. Okay, very simple really. So we get the allowable pressure that much. You see, if SPT value is given, there are ways to compute allowable pressure directly. Do you remember one thing? We don't compute ultimate capacity based on SPT. We directly compute allowable bearing pressure QA. All right? So this is very simple one. The second method is SPT, CPT value. Right, how we use CPT, I need to move this zoom. So CPT value is cone penetration resistance. So if it is the Poisson-less wall, use this equation. How easy? What you need to calculate ultimate is what? Just QC value measured from CPT test. That's it. And then for the Clase wall, we use these equations. As also Meyerhoff also suggested, it will be what? CPT cone resistance divided by 4 would be closely related with the SPT number 55, right? N55. Again, what I did here, I just tried to, how we use SPT, CPT value to calculate the ultimate bearing capacity or allowable bearing capacity directly. Okay? This is simple enough, you can have a look. So now, second part. Settlement, right? As you know, there are two ways. One is you need to calculate allowable pressure. Another thing you need to calculate is settlement. As you know already, there will be 3 types of settlement, right? Immediate settlement, we call it elastic settlement. primary consolidation settlement and a secondary consolidation settlement. Can you, hands up, you learn about consolidation in the soil in your undergraduate? I think you did, yeah? Consolidation was one of the chapter in the soil mechanics book in your undergraduate. So I'll not look at this that much now because they are the same equations we use, same process we follow. Weightometer test, we run for the consolidation, right? You remember that you did in your undergraduate? So I'll just give some equations to get the immediate settlement, elastic settlement only for now, okay? So how we calculate depends on what type of soil. If this is the saturated clay, then we just use simple settlement equation this, right? So it is given by Janbu, right? So that means there are two coefficients. You need to calculate using this graph and this graph, yeah? And you need the pressure, how much pressure is given to the foundation. Of course, you know from the what? Given load divided by the area of the foundation. So you get the pressure at the bottom of the foundation, and then B is the width of the foundation, and the E is the elasticity. So everything is known really. So you can just directly compute the immediate settlement using this equation for saturated clay. For sandy clay or sand, you see sandy clay or sand, we use little bit modified equation. Coefficients are same, right? For example, Q is pressure, B is the width of foundation, elasticity, this is mu, E value is what we call, this is the Poisson's ratio of the soil, and then also we use the influence factor. Influence factor, either you use this equation, or there is a table of influence factor here. There are values for the, what they call, modulus value, typical Poisson's ratio also you can find in the table for the type of the soil. What you need to do now, just plug in this equation, you get the elastic settlement. Good? And so we can also sometimes settlement from SPT test, right? You can directly get the SPT test. So you can, for example, if your footing is 2 meter and the UN value you get is 10, let's say just example, right? N plus 10, sorry, N value plus 10 value is that. So if it is 2 meter, what we need to do? We need to go there and then we need to read here, what? 10 to the power, what? Minus 1.5? Yeah, because this is 10 to the power 2. So that is 1 kg per cm square of pressure. So you need to multiply by how much pressure it is coming. What I discussed now is not complicated, just we have simplified the way to get settlement, simplify the way to get the pressure, okay, using SPT, CPT values and so on. Here we go. So there are some ways to calculate from settlement from CPT data. So we use these equations. Okay, that's very simple. QC is the, what we call it, the SPT measurement. Yeah, all others value is overburden pressures and change in pressure, thickness of the different layer. If you calculate one layer thickness or settlement on another, settlement in another, settlement in another, and you sum them together to get the total settlement. Last, after our tutorial, we discussed this very basic thing about what? There are different ways to get settlement and elastic settlement and what we call it the bearing pressure, allowable as well as ultimate, depending upon which tests are related. Okay, guys, now we finish shallow foundation. What do you do when you go out and then somebody asks you, I need to design the foundation, shallow foundation for this case? What do you do? These are the steps. First thing, you need to calculate load. How much load the foundation should take, like a superstructure load, any type of load. Yeah, you can calculate, right? Whatever the structure they are proposing above, the structural engineers, they give you the load. Good. Then what you need to do is you need to find the soil profile, right? What are the soil properties underneath from the test? C value, phi value, right? And then you get all data about different layers of soil underneath, all data you need. What you collected until now? Given load, and then swell properties underneath. What is the swell properties over there? What you need to do now? You need to find a zone where you need to put the footing and how deep you want to put it. It is not final. You need to do the repetitive way. So first assume this depth is enough. Then what you need to do now? After the depth assumption, you need to calculate bearing capacity of the swell. Right? So now what? You have the layer of swell and then you put the foundation below and then you calculate bearing capacity. If bearing capacity, and then from that bearing capacity, you calculate B and L, width and length of foundation. You can also calculate the diameter, right, for circular foundation. Okay, you can calculate the shape now. What type of foundation? Now you need to check the contact pressure. You see that if there is a eccentricity or not, how much pressure is given to the ground, yeah? And then also you need to check sometimes if there is a horizontal load. Sometimes the what? Footing may tilt over, right? Overturning, sliding, you need to check those, right? I will talk about this when I talk in the earth pressure theory also. And then what is the total settlement? You see, we learned few settlement equations already. So you calculate settlement and then you design the footing structure. Look at the process involved, right? So you calculate all the load, given load, you get the swell properties, you try to put the foundation at some level, some depth, calculate the bearing capacity. We learn a lot to calculate the bearing capacity equations, right? And then you find the size of the footing, and then you make sure this is not tilting, it's not overturning, right? It will be stable over there. And then you calculate the settlement, and the allowable settlement is about, for mat foundation, little bit more, but for the spread footing and shallow foundation, about 25 millimeter is usually considered. But what you need to do is you need to check the code of that country where you are designing. They have the code, okay? Your settlement should be within this limit, okay? So you need to make sure you do that. Can I ask one question now? Are you sure you can design the foundation now? At least size of the foundation, how deep it should be, and how much allowable pressure, ultimate pressure, everything you can, yeah? Are you all right?
Yeah.
Okay. So that's what is all about week 1 and 2. What you need to do is, you need to understand the basic concept and learn how the steps involved in the foundation design for the shallow foundation. Can I go back now? The tutorial problems here. Where is the tutorial for? Can I check now that one? That one. So now I want to go with this one, right? So can I check the tutorial problem week 2? Okay, let's wait now. So look at this. Now, can I go briefly over them, right? Okay, so it helps now. This is a very simple foundation. Depth is given. And then what? Width is given, right? And then you say what? Square footing, is it? Yeah, square concrete footing means length is given. And the C value is there, phi value is there, gamma is there. No water table, nothing. Very simple, and it asks you to use the Tetragrammaton method, right? That's the starting point of the bearing capacity. Good. And then second question is all about factor of safety 3. You need to get the allowable pressure. Every dimensions are given here. So what will be the load it can carry? So it's okay. You can calculate using what we learned in our. So you also need to use which method? Which method again? Tetragrammaton equation.
Yeah.
What is that? Yeah, come on.
Yes, how to find B?
Which one?
The B.
B over here?
Yes.
Okay, so you need to understand what part it affects the B. What part of the, there are 3 terms in the capacity, right? Bearing capacity, right? First, second, and the third. Which part is affected by B? Third part, right? Yeah?
Yeah, gamma B.
B in the third part. There is nothing in first and the second part. So you can calculate exactly what we call exactly the B, right? Sorry, all other first and the second term, right, in bearing capacity. Just the third term you cannot. And then what you need to do is you just try to assume Q and get some values. That's what I have assumed here. You see, B assumption is 1.5 to 3. Of course, you may not have like a 20 meter width, right? You may not have like a less than 1 meter width. It will be around 1.5 to 3, right? So that's why I gave you the answer in the range. Did I answer you all right? Yeah, kind? Because, of course, in your exam or test, B would be given. Right? Otherwise, what answer you are be checking? No way, right? But in this case, for you guys to just guess a little bit of what is the approximate B value and get the answer. So answer is, if you put what? 1.5 as a B, you get 220. If you put 3 meter as B, you get 240. That's it. Look at that. How much is the difference? Almost none, right? 220 to 240. So impact of B is very low because that's the only third term is affected. It's good. So you can check answer because of course in the test we should be given. Make sense? Just for you to understand what is the effect of different parts of the bearing capacity equation. That's what I wanted for you, right? So this is also Q given, what's the average Q given, SPT test. Yeah, you can use the equation. What the equation? Meyerhof and Terzaghi to try to get those better one. Yeah, so D given, B given, L given, unit 8 given, friction given, triaxial, because triaxial is very big value. This morning, at the first time, I consider wind is a very big, more than 32 degrees. So it is better to convert this into what we call is the plastic strain, the plane strain condition, right? So there is an equation to convert. That's the reason I wrote this phi triaxial here. So when you do, there is an equation to convert into phi. Okay, so that's all right. This is the test result. You can compare. That's what we did this morning. Yeah, is it all right? Yeah, we did this morning, and then this is we did last week. Yeah, a most difficult one we have done, guys. Believe me, we have done most difficult one. Just easier one for you to practice. All right. Okay, so now this is very easy. What methods? Again, Terzaghi, this is extra some practice for you. Okay, so you need to calculate B now here because there is a load given anyway. Load given is you can calculate back the size of the footing. So this is which method you need to use? Meyerhof and the B6. B6 is little complicated. Meyerhof is very easy. Got it? Yeah. So there is a water table. Just to understand the effect of water table I discussed today. So only the water table will affect only the second term and third term, depending upon where the water table is located. Okay. There are ways I have explained a lot. So you can calculate that which method we need to use. Basic method, right? Okay. And then this is what we did today. Yeah. Explain, isn't it? Now done. Look at this, done. All the tutorial for weekend 2, most of them we have done. Now, Karen or any of you, could you please try that I haven't done, right? And then if you have a problem, I'm happy to solve for you. I am happy to discuss at least. Okay, your job now is what you need to do is, could you please solve this all problem step by step, neat and clean in your exercise book, right? The exercise book, so that you know where is wrong, where is good, where is not good, so we can discuss if you have any problems. Make sense? Good. Okay. Can you finish that all? So before I finish today, I'll finish quick, guys. I don't want to just keep talking. My throat is not doing good. Can I go to my unit website before I show? So what I do is I will upload the assignment 1. And there is a chart questions. No, so there is a book thing. I do have where I took this information from, right? Yeah, I do have, but there are so many books I use. It's so boring if you go through those old books, all right, Pema? Yeah? So it's better you just follow my lecture note because they are more detailed. And if you have any confusion, could you please ask me? You don't need to, because you see, I combine like 10 books to make my lecture note, right? And I can't follow just one book and one method. That is not fair for you, because you guys are at master's level. You need to see different methods, comparison, how you compute those things. So it may not be that good idea to get one book and just follow one book, right? So just go through my lecture note. Hopefully they will be very helpful for you, right? If not, if there is unclear something, then you need to ask me. Again, don't go like line by line what this sentence means. Okay, that is not what engineers we do. We just try to get the overall idea, what equations are used, which tables are used, and then we compute, we compare, right? That's what we'll be doing. So I'm not opening your Moodle site now, but what I do is I have around, how many students? Around 11 students now, right? Do you want to work in the team based on your choice, or you want me to allocate you in different groups randomly? What would be better option? Doesn't matter, right? Yeah, you are ready for both cases, isn't it? Right? So now first assignment for you is based on group, right? Maybe maximum 3 or 4 people, or 3 or 4 of you work together. It's about researching something. Okay. Do you have something very good idea? I want to know about this in regards to geotechnical engineering. Maybe some foundation design, maybe some good technique, anything. If you have, it's a free, right? It's a free research type of things, right? What I ask you in a group, you investigate, and then you do the literature review. You want to have some understanding about, for example, let's see. This guy, this lecturer, only talk about very basic type of footing. What happens if I go the vibration, right? Like a machine foundations. I want to learn more about that. If you think like this, okay, why not you make a research paper based on dynamics, soil dynamics or foundation for machines, right? And then investigate, you learn, and then write a report about it, okay? First assignment is you need to investigate in your interesting topics, right? And then what you need to present in front of us. You will be presenting from Zoom, all right? Using like this. So I will just keep listen to you and then you guys present in the team. So can I quickly go to that particular assignment? I'm designing now. I haven't opened, but I'll open soon, all right? Can I go back to 2012? This is the one, assessment items, right? That's the one. So can I go to the first assignment just to see, right, what I'm planning to design for you? This is the first assignment, 30% is a team project, right? It will come to you, right? Look at here. So you can see, right, my computer? Yeah, okay. So now what you need to do is, look at this. These are the tentative topics I have given you, right? Yeah, for example, that's why I wrote here, not limited to. You don't need to stick with one of those topics. Okay, but topics should be very advanced level. Topics cannot be like, I want to get consolidation test, research on consolidation test. That is not fair. I'll not approve those. If you want to get, I want to get a research, I want to do a research on sieve analysis. Okay, forget it. That's too basic and fundamental, right? So you need to check the like advanced level topics. Can I ask a little bit? Following topics are recommended for research, right? However, you can choose your topics based on your whatever you be interested in. All right, that's free for you. Some topics is what? Advanced ground modification techniques, right? For example, if you go to some field and you found out soil is really bad. Okay, so how can I improve this soil? You investigate in that research. Modern soil reinforcement techniques. So now, how can we put something geotextile, geogrids, those type of things to make soil better? It can be, what are the good techniques for the site investigation? What is critical state soil mechanics? What is unsaturated soil mechanics? What is soil dynamics? I was mentioning before, right? Soil dynamics, treatment of bad soil, how we design the foundation on expansive soil. There are topics given, right? In your team, right? Discuss each other. I'll upload this soon, right? You discuss each other, right? And then investigate. Okay, how can I do that? And make a paper about it, right? Like, you see, you are in a master's degree, not just doing assignment, but doing research is a lot better than, because I cannot cover everything in the unit. So you choose one of the topics, and then you investigate, and then you write a report about it, like a research paper report. Is it clear? Any questions? Okay, so I'll upload this and then you are free to go. So this is the 30%, very big marks is carrying, right guys? So please do very well. It includes both presentation and the report. I will also upload the report format, presentation format, those type of things, right? So you investigate, you research, and then you do. You don't need to wait now. You can immediately start doing research on some of the topics you are interested in. It's free type assignment, but you need to prove us that, prove me, or maybe I'll invite some other academics to evaluate your presentation and research, right? So what you need to prove is, okay, this guy or this group knows everything about the topics. You need to convince us about that. It's good? Okay. I think I'll stop here. So we finish 1 and 2 weeks. So we will, on Wednesday, we will start a little bit on numerical modeling using the GeoStudio software, right? Yeah. And then we will, from next week, we will start the deep foundation, like file design, those type of things, right? We only cover until now just the shallow foundation. We will cover about the deep foundation next. Okay, next 2 weeks we'll cover deep foundation and then go for the retaining walls and the slope stability and so on. That's the same topics you learn in your undergraduate, but it will be more advanced, okay, more detail like what we discuss here, different equations, comparison, those type of things, okay. Okay, any questions you have? Come on, you can put in a chat or you can talk, you can do whatever you want. No? Very quiet? Okay.
Hello, sir.
Yeah, come on.
Can I ask tutorial question 1.10?
Yeah, sure.
Yes, when we substitute PV,
Yeah.
and what's the number that I have to substitute for H?
What is that? H is here. You see now we at the beginning how deep it goes. First we calculated H here.
Oh, I have to substitute that H value?
Yeah, I think there is an equation. What is the equation? Can I see that? What is that means is,
Yes.
what is
PV
H?
equal to, yeah.
What is that H?
PV equal to Q bar D1 plus. Yes,
Oh,
just up there. Yes.
Oh, that's the only top part. This is only the top part, right? So if H is first, you know integration how it works. So you need to put 0.6 first here, right? It's a 0.6. Can you try now? Can you compute? You need to put, look at the integration sign here, right? It varies from 0 to that. And then you are talking about small letter H, right? Lowercase letter. I was thinking the uppercase, so I discussed different thing, right? That is not correct. So what is correct is this H, how you do integration here is like this, right? So this first time you substitute H equals 0.6, and second time you substitute 0. When you do 0, that means it becomes all 0, isn't it? Yeah. So can you put 0.6 and a try? Can you get this now? Can you try the computing? Come on, guys. Can you do 17.25 times 0.6 times 0.6 divided by 2? You get this second part. So can I just show you? I think integration, I thought you knew integration thing, right? So for example, and I think you know just the confusion thing. You see, when integration sign is this, right? Let's say this is from A to B, right? Yeah. So if anything here, fx dx, right? Any function with the integration dx, right, over dx. So once you calculate this value, whatever it comes, then what you need to do is after evaluate, you need to put fb, what is at the top, right? And then f minus fa. Okay, whatever function you got after integration. So this is what the area of under the curve is all about. Okay, so the first time you put 0.6, second time 0, so that means you don't need to put this part now. This becomes 0 already, right? Yeah. Only the first part you need to use in there. Yeah, that's it. Did I explain all right?
All right, sir.
Okay, good. Yeah, I thought you know this integration thing, so I just quickly run
I
through.
forgot it.
Yeah, no, that's all right. Yeah, that's okay. Good. Okay. Thank you. Yeah, you see you on Wednesday. Wednesday, what time is it? It's where is it?
10
Right? Wednesday is still 10, isn't it? Okay, good. Thank you, guys. See ya.
Thank you, sir.
Okay, bye. Yeah. Okay, good. And meeting.